Welcome to nature's nano.
I've always wondered how butterflies and beetles can make these strong iridescent colors. So if we take a butterfly wing and we put it under a microscope, we see thousands and thousands of small little bright blue scales. Each of these scales is covered by little ridges running across the scale. Each of these little ridges, if you cut right through them, look like a Christmas tree.
This structure is finely tuned to reflect only the blue part of light, so the butterfly appears bright blue.
If we just replace the air in this nanostructure with a bit of liquid, you'll see that it changes its color from bright blue to bright green.
It fills in the gaps around the nanostructure and makes it better at reflecting green light. When the liquid evaporates, it returns to reflecting blue. Please, don't squirt butterflies. Life has spent 3.8 billion years finding clever ways to use the nanoscale. Now we can understand nature's nano secrets. We can use them for ourselves. Many tropical plants have leaves where water just runs off. This keeps them clean. If we look at the nanoscale, we can see tiny structures which stop the water from sticking. By copying these structures, we can make our own water-repellent surfaces. Some that even honey doesn't stick to.
Ants have really cool feet. They can stick upside down to surfaces, holding up to 100 times their own weight, without falling down. We look closely, we see tiny little pads on their feet that help them to stick.
By investigating the microstructure of insects' feet, we can design surfaces hard for them to climb. Bad luck for cockroaches. Pitcher plants eat insects that slip into them, but they don't work unless all of their rim is covered in water. To make sure they're as slippery as possible, they have a nano trick up their sleeves.
You can see how the water spreads, even upwards, against the gravity. If we look at them, we see that they have lots of grooves running across their rim. And in between these grooves, if we look on a nanoscale, there are even smaller grooves.
This is called a superhydrophilic surface, which means that the surface likes the water and pulls it across itself. Once the water is spread thinly across these micro and nano grooves, they become very slippery, and it's goodbye ants, hello pitcher plant dinner. Hydrophilic surfaces have lots of uses, but one particularly excellent one is in a new water filter. This can filter even the tiniest bugs from dirty water, making it safe to drink. Even really dirty water. Looking around the natural world is a great way to pick up ideas for things to make ourselves. But with nanotechnology, we can make new structures that nature has never even tried.